Hi viewers, welcome to LMO Solution. Today we are going to see about neural network MPPT controlled PV wind battery system, and also it can be called as islanded hybrid AC and DC microgrid. That means system will be operated in island and mode, and the wind energy conversion system and the solar PV system will be controlled by means of neural network MPPT control concept. In this simulation model, the neural network will be receive four inputs. One is VREC and IREC, and then VPV, IPV. VPV, IPV nothing but PV voltage and current, and VRC, IRC nothing but the voltage and current of the rectifier in the wind energy conversion system. So here you can see that it consists of different system like wind energy system. This one is wind energy conversion systems, and then solar PV, and then we have battery storage, and then we have islanded inverter control. In wind energy conversion system, we are having wind turbine. Wind turbine is rated around 2.9 kilowatt, and then we have PMXG generator, thermal magnetism generator, and it going to be, and that means the output of PMXG going to be connected to the rectifier. So rectifier going to be convert the AC into DC, and then this DC power, right, going to be processed via this boost converter. So this boost converter going to be controlled by means of this neural network. So this neural network MPPT going to be decide duty cycle based upon this VSIRC. Already I told the rectifier voltage and current. Based upon VSIRC, it going to be decide the duty cycle. This duty cycle is processed via this PWM generator, and this PWM generator going to be generate the pulse to control this MOSFET in the boost converter in order to extract the maximum power from the wind energy conversion system. So this boost converter going to be connected to this DC bus. So here the DC bus going to be maintained at 400 volt. So next you have to see about the solar PV system. This is a PV panel. The PV panel rated at 2 kilowatts. When you could open it, we can see that number of parallel string is equal to 1, number of series string is 8. That means series connected model per string is 8, and the single panel is rated at 250 watts. And then you can see the different parameter like open circuit voltage, short circuit current, voltage at maximum power point, current at maximum power point. Here we are using 2 kilowatt PV panel, and it will be connected to the boost converter, and then the output of boost converter is connected to the DC bus as well as this DC load. This boost converter also going to be controlled by means of this neural network. This neural network going to be decide this second duty cycle based upon PV voltage and current of the PV panel, and it going to be processed via PWM generator. It will generate the pulse. This pulse going to be control this IGBT of this boost converter now to extract the maximum power from the PV panel. And already I told the DC bus voltage here we are going to maintain at 400 volt. So in order to maintain the 400 volt, here we are using energy storage system. So here we are using battery model. So battery model we are using here is 22 load batteries, and then it going to be connected to the DC bus via this bidirectional converter. This bidirectional converter going to be controlled by means of voltage control method. That means you are going to measure the DC load, that means voltage at the DC load, and going to be compared with 400 volt, and going to be processed via PA controller. The PA controller will be provide duty cycle is going to be processed via PWM generator, and then it will generate the pulse for this bidirectional converter. This pulse going to be control this 2 IGBT of this bidirectional converter in order to maintain the DC bus voltage around 400 volt. And also we are connecting AC load in this common DC bus via this full bridge inverter and then LCL filter, and then here we have two loads, each load having that means 1000 watts, and then another load having 1400 watts. So initially this 1000 watts is connected to the system, and then this 1400 watts load will be connected after 2 seconds. And then here you can see that DC load, here we are using 1000 watts DC load. And next you have to see about the wind speed, that means wind speed command for this wind turbine. Here you can see that initially the wind speed is maintained at 12 meter per second. After 2 seconds it going to be changed to around 0.2, and then we have to see about the irradiation. So here you can see that every 0.3 second I'm changing the irradiation from 1000 watts per meter square to 500 to 10 watts per meter square, and then again it changed to 500 and 1000. So irradiation will be changed for every 0.3 seconds. This is a total model of that neural network MPPT control PV in battery system. Next, I'm going to test the model. Not to test the model, I'm going to simulate the model. I'm going to open the all scope parameter. Now I'm going to simulate this model as per our settings. That means initially radiation will be 1000 watts per meter square and wind speed equal to 12 meter per second. We will see the result of PV and wind and battery all detail. Here you can see that we are getting PV voltage around 250 volt. The current around we are getting 7 amps, and then for 1000 watts or meter square you are getting around 1900, that means 1950 watts. For 500 watts per meter square you are getting the power around 990 watts. And then here you can see that this rectifier and boost converter power of that wind energy conversion system. Here you can see that we are getting almost 2.9 kilowatt. Here you can see that for 10 watts per meter square the PV power is equal to 0, and then you can see that the power of current of the PV is 0, and the voltage of the PV is around 50 volt only during low irradiation condition. And then irradiation changed to 500 watts per meter square. Because of that the PV power is generated around 990 watts. After 1.2 seconds the irradiation changed to 1000 watts per meter square. Because of that we are getting around 2000 watts from the PV panel. Almost the maximum power is extracted by means of neural network in both PV and wind energy systems. And also here you can see that because of variation of PV power, so you can see here that means the charging current on the battery, it will be very initially is around minus 7 amps and then minus 5 amps, and then it comes to minus 10 or minus 11 amps. So now we can see that and the after 2 second rate wind speed change from 12 meter per second to 11.2 meter per second. Because of that you can see that the power of the wind energy conversion systems goes to 2000 watts. Here batteries keep on charging mode condition. Now we can see that the battery current goes to nearer to that is around only 1 amps. And here you can see that this is DC bus voltage, and DC bus voltage is almost maintained around 400 volt, and then this is DC load current, and then this is DC load power is maintained around 1000 watts. And here you can see that this is load voltage, load current, and then this load power from 0 to 2 second, right? We are connecting 1000 watts AC load, so you can see that the load power is around 1000 watts. After 2 seconds we are adding another load having rating of 1400, totally 2400 watt. Here you can see that we are getting 2400, and also you can see that the power and current, voltage and current. So this is the voltage of this load, this is the current of the load, and this is the power of the AC load. And here you can see that this is the inverter voltage and the current. Here that means power balance is maintained between source and load with the change in irradiation and the change in wind speed condition. This operation of the neural network MPPT control the PV wind battery energy storage system. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.